Summit today trainer as a Hadoop Big Data trainer, and I am taking today session of the Hadoop Demo class, which consists of few topics. We will be going over all the Hadoop ecosystems components, basic idea, and how they are interacting. We are going to cover. Should we start ahead or we will wait for someone? I don't know basically how many people should join, but as of now I could see only one.
Yeah, actually I was supposed to join from another computer, so I'm just sitting with Lingam.
Oh, great. And not a problem at all. So will you go ahead?
Yeah, I think so.
Okay, some background noise is coming. Can you?
It's fine.
So,
okay, just give me 1 second, okay? Please.
Sure.
Thanks.
Today's session is based on what is Hadoop and why we are going for big data dealing with Hadoop, and previous approach what was there. So right now we are going for Hadoop. What is the good features involved with the Hadoop, so that we will go ahead. So before to the Hadoop, we know that lot more technology was there. Hadoop is not a new technology, everyone knows that, but people are telling very new technology. Why? Because the framework itself is a very new, but the technology inside the framework which is an inherent technology from the other components, like Teradata, HANA, even Oracles, some of the databases which they are InfoBright, they are doing a lot of optimization inside MySQL, inside your core frameworks. These are the features which is available to the RDBMS. People are taken that features and integrated with one framework, that is nothing as a Hadoop. Hadoop is a distributed data access and distributed data processing engine. So in top of Hadoop is divided into two parts. One is the core infrastructure, another is the ecosystems. The core infrastructure is laid on top of the distributed file systems, which is a common to everyone. That is a shared file systems. If we are going to the previous technology, we have a NTFS file systems, we have a ext3 Linux file systems, we have so many file systems. The file system, what exactly these file systems and what is the difference of the Hadoop file systems? If we are going to the Hadoop file systems, it is a shared file systems, and everyone can share with that file systems. That means
Which
like
file
that
system
if you are
mentioned?
Sorry, Hadoop HDFS file systems.
HDFS, okay.
Yeah, HDFS is a distributed file systems. Is a Hadoop. The name stands for HDFS. S stands for Hadoop. D stands for distributed, and Hadoop distributed FS stands for file systems. The way of interacting to the Hadoop file system is the separate than the way of interacting to the normal file systems. If we will go to our normal file systems, you could see that CDE drives. So these are not file systems. When you are storing a file or creating a file inside CD or E drives or any of the Linux drive, if you are going to create a file, that time what happens? One entry should be there in a file allocation tables. That file allocation table contains what is the file name, what is the size of the file, when it's created, when it's modified, all the attributes. That is the metadata information. So a file system only holds the metadata information. Other than that, nothing. But in a Hadoop file systems, it's a little more different than the usually file system what we are dealing with that. So in Hadoop file system, what exactly it is happening? The size of the file systems varies from the minimum by default size 64 MB to 128 MB, but it can be changeable. With, based on our request, based on our configuration, we can configure it. But normally these people, the framework who supported from the Hadoop side, these guys by default they set it as 64 MB to 128 MB. Why so large file systems? Even if we are comparing these file systems with the previous approach of our operating system file system, operating system file system size is only 4 KB to 6 KB. Why in Hadoop it is 64 MB? By default 64 MB. Due to that, everything what exactly we are handling with that, entirely dealing with the file system. This is the major component we are dealing with the Hadoop. That is why in a Hadoop infrastructure, if you are going to the framework of the Hadoop, there is a two layers of the Hadoop framework. There is a core infrastructure and also there is a ecosystems. The ecosystems component are nothing as a program or technology on top of the Hadoop distributed file systems. So I'm picking one point. HDFS is a Hadoop distributed file system. So we are very experienced person that to do some analysis, to do some arithmetical calculation, to do some calculation, to do some manipulation, we needed two layer. Two layer means one is the data access point layer, another is the processing engines. So data access means where we will get the data. First thing we have to load the data. So if you are going to the layering of the data, that case what happens, first is the import of the data, second is the data processing, third is the outcome from the data. So the data access layer, we know their data access layer, it could be from the social media, it could be from the RDBMS, it could be from the any of the flat file, it does not matter. So Hadoop is a framework which will support you to bring the data from the various resources, various point of data. So that is why it is named as n-directional entry point for the Hadoop HDFS. So I'm going to share some of the few, I'm going to draw some diagram which will clear you how the data layer is. This is HDFS, and basically this HDFS, this is Hadoop distributed file system. Yeah.
Samir, got a quick question here. So you mentioned that 64 MB to 128 MB. What was that? That was a block size?
Yeah, great. So the block size, what exact?
Okay.
Go ahead.
No, go ahead.
Yeah. So the block size, what exactly Hadoop is following, when we are loading the data, that time what happens, the data, usually when we are loading the data to the RDBMS systems, that time what happens, only single point of failure. If entire database, that means the centralized database is going to crash, then what happens, entire data will lose. Is it right?
That's right.
But thing is that lot more people are implemented the replication factors. The replication factor is nothing as a clone to a same copy of the data. Got it? So now
yes.
What happens? Now what happens? The data file which is there in a file system, when we are loading the data, let's assume that I'm loading 1 MB of data. Let 1 MB only, very small size of the data. If we are loading 1 MB of the data, if I load to the any DBMS systems, if that system going to crash, then what happens? Entire data will go out. But in Hadoop file system, Hadoop HDFS structure is not like that. What happens? When you are going to load the data 1 MB, it will be there based on the replication factor. What is the replication factor? In high level, replication factor is a clone of a same data set. Suppose that 1 MB data set, if we put the replication factor as a by default 3, then the data will be inside HDFS, it will be 3 MB. Then the question is coming that why it is like that? Because due to it is supporting for the fault tolerance. That is why Hadoop is a good framework to support you loss of the data. That means never the data will lose. So what happens? How it is creating? How it is preventing us to lose the data? There is a few more points is here. First point is that when we are going to load the data, Hadoop engine or Hadoop framework will first check either what is the replication factor you define, or the business define, or the model define, or the job define. That cases what happen, it will pick the replication factor and it will pick the data from the source and it will create a block. That block size, whatever it is creating, each chunk, the block is nothing as a chunk size. The chunk is nothing as a split or just subset out of a big data set which is in the source side. So let's assume that 10 GB of file, I'm loading the data. It will not load at a time 10 GB to the HDFS. What happens? It will create a bucket, or it will create a split, or it will create a subset out of 10 GB and it will load the data. Each subset, let 10 GB divided by 64 MB equal to the amount which is coming, that many times the data will be there as a replication factor 1. But if we are putting replication factor as a 3 into 3, that many times the data will be there. So at a time, the subset value will be 64 MB. Why? Because due to reduce the latency involved with the file system interaction with the IO operation. So what happens, instead of reading 64 KB file, because Hadoop is for big data does not make sense if the data size is within a GB. Only people are thinking big data means it could be more than the terabytes. Other than terabytes, I have a Oracle, I have a MySQL, InfoBright, I have a Teradata, I have a HANA. These guys will handle some GB of file. There is no problem at all. Their framework is so strong. So for due to that constraint, whatever they did, if data is so high, means more than 1 TB, more than the TB file, then when you are loading the data, that cases it is dividing the entire data set into subset. That subset is nothing as a block, and that subset is nothing as a split or subset. It is going to load the HDFS based on replica factor. Let's assume I have a data of 10 GB here. 10 GB. Now 10 GB I want to load to HDFS, it will not directly load to that. So I'm sharing some slides which will give you the clear picture how it is happening. So that cases you could see my diagram which is telling Hadoop map reduce processing communications, how exactly the job is interacting with each other. Before going to this slide, I want to introduce you some of the components of the Hadoop and the Hadoop ecosystem. The Hadoop, on top of the Hadoop framework, actually Hadoop framework is not consist of one component. Hadoop framework is consist of few more components. Assume first component of the Hadoop framework is name node, which is a primary or the master node. And the second component associated with the name node is the data node. And the third component, which is dealing with the client communication or the job specific communication, is a job tracker. And where exactly the job is rolling out, that is known as the task tracker. So if we are going to that, all the components, name node, data node, job tracker, task tracker, and another is the secondary node name, which will support for us to retrieve the data in case the cluster or the system will down. So that case, each and individual components in a Hadoop framework is nothing as a daemon processes. What is the daemon processes? Daemon processes are the initial processes need to start on before running any job. Like that, if you will go to Oracle also, there is a daemon processes. If we will go to the Teradata also, there is a daemon processes which will support you or the client to start the job. Here there is 5 daemon processes, major daemon processes in Hadoop framework, that is Hadoop 0.2. So Hadoop is a distributed component or the framework which is first initiated in a Google, that is we know that is a GFS, Google File Systems. But inherently, these features came to the market through a guy named as a Doc Catting. He introduced that framework and modeled it, and he published that. That is an open source project under Apache, and it is nothing as a Apache Hadoop. So in a market, actually, Apache Hadoop is a father of all the Hadoop distributors. Let Hadoop distributors, one of the Hadoop distributor is Cloudera, Hortonworks, Mapr, IBM, all these guys, Amazon Web Services, AWS, EC2 systems. These systems are inherent technology of the Apache Hadoop, Apache Hadoop. So that is a core part of the Hadoop framework. People are taking and they are implementing their own features, their own components on top of that, and they are publishing to the market. So these features, if you are going to any of the distribution, either Cloudera, either Hortonworks, either Mapr, or any of the IBM or custom-made through your companies, it does not matter. But each and every Hadoop framework should have a 5 daemon processes. That 5 daemon processes: name node, data node, job tracker, task tracker, and secondary node name. This is the basic features of the basic components of the Hadoop framework. Each and every component of the Hadoop framework, they need to talk with one central point, that is shared file system. This is nothing as a HDFS file systems. Now see the very high level diagram I'm showing you. Let's assume that you want to load the data into the HDFS for 10 GB file. So what happens? Client will request to that. So how it will happen is that I'm sharing some diagram so you can get better idea. See, client is the top, and client want to interact with the HDFS. They no need to go directly, so there is no way directly to talk with the data node. So data node is a slave node, name node is a master node. So how the communication will happen? Client will request to the job tracker will get the request from the client what to do. That time the first point, client interacting with the job tracker. Then second, job tracker wants to interact with the task tracker. What is task tracker? Task tracker is nothing as a who actually running the task. Let's assume that select star from table name. That is a task. Select star from table name where condition. So that is nothing as a task related to a particular job. So that select star from table name will be distributed across the data node. What is the data node actually? What is the name node? The name node is a controller, the data node is a slave, and which they all are interacting with the name node through a DCP protocols. So now the communication layer between data node and name node is nothing as a SSH protocols. That is secured cell. This secured cells is a very high levels. So we have to that secured cell communication is based on RSA tokens. It is not new to the Hadoop framework. It is very old concept. You know that VPN connection, RSA tokens, you know all the things. That is like that same features, it is available here, but we need to configure properly. So now here, what happening? The job tracker is associated with the name node. So how it is happening? Client is requesting that I want to copy the data. That time job tracker will ask that, hey, I need the token which will tell me under which node I will put the data. So that cases job tracker, the name node will reply that yeah, these are the data nodes available and these are the data nodes data size available for each individual machine. So now 10 GB file, instead of storing in one hard disk, it will store in HDFS. So I'm going to draw some diagram which will give you the better idea how the HDFS is going to construct. Or I will share some of the diagrams.
Just a quick question here.
Sure.
Okay, so the earlier picture, the one which you mentioned, basically the data nodes, the slave ones, so basically each data node belongs to individual workstation or individual server. Is that right?
In individual workstation.
Okay. So basically, data node is based on the machine, based on the individual hardware. Right?
Based on the individual
hardware has its own hard drives, basically.
Exactly. So I'm going to share you whatever you are asking. It will be give you the better idea. See, these are the high level concept of the HDFS related with the data node and the name node what you are asking. So now the high level diagram, the central point is the name node. You could see here the name node host 1. The name node host 1 may contain the hard disk, it does not matter. But the hard disk which is associated with the data node, it should be in the part of the HDFS. The point is clear or doubt?
No, not yet. Can you repeat again, please?
Yeah. So the name, there is here consider two parts. One is the name node, another is data node. So data node is a workstation or that where exactly my work is going to play. Clear?
Yes.
The name node which directs the job tracker where to push the job. Got it?
Okay.
So name node is nothing as is one kind of routers. Got it?
Yes.
So now name node will tell you how many data node associated with one cluster. One cluster contains n number of physical machine, dedicated machine, and they each one connected with n cables. Now host 3, 4, 5, 6, if you will see middle row and the last row, these are the data node. The data node is nothing as a physical system having hard disk and RAM. Now each of the data node will have a associated hard disk. So when name node will ask that, hey, give me the space, I am going to put some data under you. When the name node is requesting to the data layer, means data node is telling, we don't know because we are individual guys. How we will know that? So that cases, one technology in between the name node and data node is there, which is going to tell you where you need to push the data. Either you have to push the data under host 3 or 4 or 5 or 6. Now that middle layer, what exactly it will be there in between name node and data node, that is nothing as a virtual layer. That virtual layer is, I'm showing you what exactly the virtual layer. See, this is my data layer. So one virtual layer, it will be here. Now this virtual layer is nothing as a HDFS.
What did you mention? Oh, virtual layer is HDFS.
Okay, exactly. The HDFS is not a physical concept. It is a logical concept which is going to construct the HDFS space equals to the sum of all the data node hard disk space. Any doubt?
No, we got it.
So we know that data node, suppose the data host 3, host 4, host 5, host 6 contains 4 hard disks, each one 4 hard disks. 4 hard disks indicates each hard disk is 10 GB, assume that 10 GB. So now first host 3, 40 GB, 40 GB, 40 GB, 40 GB. So now how many size total of HDFS size? The total size of the HDFS equal to sum of total space available inside a data node.
Okay.
It will be 40 plus 40 plus 40 plus 40, right? 160. Got it?
Yes.
So now 160 will be the size allocated for HDFS. So that HDFS, when client will copy the data, client will think on top of 160 size, not individual host machine size. Got it?
Yes.
So client will copy the data through name node. Name node will tell that, hey, wait. Before copy that, I have to tell you where you have to put the data. Then client, the name node will reply one token associated with the host IP, and the client will copy from the source location the data to the individual machine. This process will keep on happening end of the file. So each time client has to take one token from the name node, and that token is associated with a data node IP address or host name, and what is the physical storage size of that particular machine. Then the name node will respond to the client, hey, these are the tokens available under this cluster. So if you want to copy this. So when it will going to copy, now I have a 10 GB file. 10 GB, it could be stored in a different host, like host 3, 4 or 6, or it could be stored in host 3 and 4, or it could be stored in host 3 and 5, based on the shortest path algorithms. What is the shortest path algorithm? Which node is very close to the name node, it will store first that. Then the next. So the distance computation is based on shortest path algorithms. It is framework itself, it will provide you, no need to write any code. So where exactly we are going to write the code? We are going to write the code only this place.
So Samir,
The point, yeah.
Samir, the connectivity between the nodes is normal LAN, which is like 100 Mbps.
Exactly, it is in normal Ethernet card of 100 Mbps speed, and if you need show high-end speed, you can increase your LAN capacity based on your consumption of the data or the source of the data available to that, and it's based on your configuration, but purely it is based on Ethernet communication. Is a LAN.
Okay, so you don't need to have like the fiber or any other fancy network connectivity between the servers.
No, nothing is required. And total the framework, the Hadoop component, the total framework is free. No cost involved with the software related thing. Just how much machine you are buying, what is the cost of that, that's enough. Now, the fantastic algorithm inside the Hadoop framework, I am going to tell you what is the benefit people are looking for Hadoop nowadays. I'm telling you, now you have a laptop. Now some laptop size is 500 MB, 1 GB RAM. Some hard disk size is 500 GB, and some of the laptop is having 128 MB RAM, and hard disk size is only 1 GB. I have this laptop also. I have a lap which contains 128 MB RAM and let 1 GB of hard disk, and you have a laptop which is the configuration is 1 GB RAM and 500 GB hard disk. Like that, various configuration, various physical machine is available to the cluster. So what and how we are going to associate it? These are the machines inside a cluster. Cluster means Hadoop framework. Now coming to the picture, we know that what is SDFS? SDFS is the sum of total hard disk space available to a particular cluster. That means the hard disk, I am going to support you hard disk space is a 1 GB. You are going to support me a hard disk space of 500 GB. So total space available inside a HDFS equals to 500 plus 1 GB. So 501 GB total space. Now I am going to see I am able to utilize my system which contain very less hard disk space. So that is nothing as a reutilization of your machine in proper way. So there is no other concept looks like other than distributed or the shared file structure. You could share your very less configuration machine associated with these clusters. So this is a great advantages of the Hadoop framework.
So Samir, just one question. So basically, sure. You in the Hadoop cluster, all those nodes, you don't need to configure those hard disks with any of the redundancy, right?
We no need to configure it, but we should have an idea that based on our data size. Suppose that I have a 501 GB of hard disk total SDFS, but I have data is 1 TB. That cases I have to think more based on the data. That is why Hadoop is divided into 3 layers. One is the data processing engine, another is the data outcome from the processing, and the first part is the data input. You have to consider what is your input data size. Based on that, you have to choose a physical machine. That is from the client point of view.
So Samir, my question was, like usually on the server side, right? What we do is we have either RAID 1 or RAID 5, so hard disk configuration. So basically it's like a stripe mirror. So yes. In this case, what's the normal practice usually? I mean, do they have like the RAID 5 configuration, they do it, or no, they don't worry about that and just use the hard drive as it is, like a raw hard drives, and no RAID configuration for any protection of the fault tolerance?
Yeah, no. Whatever you are telling, it is perfectly right. It is a RAID configurations. But other than that, you can utilize your very resource like there is a concept of in the Hadoop framework, there is like a scheduler and the shared scheduler and the capacity scheduler. So capacity scheduler, it will configure into the framework, it will take care of the part which node contains what is the configuration, and based on that it will push the job, not more than the capacity, beyond the capacity. That case, whatever you are telling, this is standardized. It is also associated, it is also there in Hadoop framework. Along with that, there is a process we can go and we can configure based on our machine resource available inside the capacity schedulers. So capacity schedulers is nothing as a which will determine the capacity of a particular physical machine going to run a job. Is it clear?
Yeah, that's fine. That's fine. I was just talking more in terms of you know, the mirroring at the disk level.
Okay. So
and
the high
level.
Sure. So the mirror copy of the disk levels is purely in Hadoop framework based on your data size. That means it is not a thumb rules. There is no thumb rules. You have to use this much of hard disk or this much of like that. No. The selection of a hard disk size is directly proportional to your input data. One way of selecting the hard disks. Second way of selecting hard disks, what I discussed. We have to configure some fair scheduler and capacity scheduler. Based on that, we have to write some algorithms which will determine which machines contain less space and which machine contain what is the configuration of the machine. That's all. Based on that configuration parameter, we have to push the data into that. But mind it, we told already that the block size is 64 MB. It should not less than 64 MB, the hard disk space. Got it? So it should not less than the space which is associated with 64 MB. It should be more than 3 times of 64 MB. That means more than 64 MB, because maximum replication factor people are following as a 3. Replication is nothing as a copy of same blocks. How many times? That means replication factor is 3. So one packet will be there 3 times in the data node, in a various data node, not one data node. So if one data node is failed, and second data node will provide the data. That mechanism is a framework supported mechanism. We don't need to write any algorithms for that. Just our focus point is that, see this diagram, just we have to write this green part, light green part, map, combiners and reducers. Other than that, nothing. And some advanced features is there on top of this map reduce, that is nothing as a file system interactions, like a batch processing. I have a cluster 1, I have a cluster 2. The scenario is that I want to copy the data from cluster 1 to cluster 2, or I want to take a backup. For that purposes, yeah, we are going to deal with the file systems, and we how to take a backup, how to take a data backup in a daily basis or hourly basis or monthly basis. How to do that? How to do that batch operation? How to do that analytics on top of that? These process, to support these processes, there is various ecosystems component which I already shared with you. The various ecosystem components on top of ecosystems like a Java, C++, streaming API, which we are going to use to write a custom map reduce, which will do the operation what we need for that, our specific. And like that, Hive is a data warehouse purposes. We are choosing one of the component, Hive, HBase, Peak, Jupyter, OG, Impala. All these components are on top of the HDFS, that is nothing as a Hadoop. So entire framework is consists of a Hadoop, is named as a Hadoop framework. Hadoop framework, it does not mean in the HDFS only. It is consist of a heterogeneous components. It's a purely open source. Each and everything is purely open source. Like that, suppose that I want to write a prediction engines or analytics engines. How to do that? In a Hadoop also there is a ecosystem component named as Mahout, which will support you to do a predictive analysis or a segmentation or a market analysis. Like that, we could do these things in a Mahout engines. But other than Mahout engine, there is a way to do is that custom map reduce. If you are so strong in Java, C++ API, you can write your code based on the requirement, and you can fetch the data from HDFS core infrastructure, and you can do the processings and load the data again back to the HDFS. From HDFS, you can interact with the RDBMS. So Hadoop is telling, I'm a friend, I am not, I didn't come to the market to replace any of the technology. It does not mean that like that Hadoop will do everything without RDBMS. No, it is not like that. It's like that RDBMS will be there. Yeah, whatever you are doing, it's fine. Suppose that you are doing some job right now. Right now you are dealing with RDBMS like a Oracle or a Teradata or some HANA. So that data is already there. We are using a warehouse purposes right now, some HANA or Teradata. How I will bring the data to the HDFS or into the Hadoop? That cases we have a integration layer with relation to the RDBMS. So how to bring the data from RDBMS to HDFS? There is a component, ecosystem component that named as a scoop, which will support you to bring the data from RDBMS to HDFS. And again the back process from HDFS to RDBMS. And like that, there is another package inside a Hadoop framework is a NoSQL package. What is NoSQL? NoSQL does not mean that never SQL. It is like that, not only SQL. So what exactly SQL will give you? SQL will give you a standardized syntax and methods and very high level like that SQL statement. If you are writing, we are able to fetch the data. But other than that, we are able to write a program which will do the same operations. Like that, select star from table name where the condition is based, where condition is something. So that program we can write in a Java or C++, and we can deploy into the Hadoop and we can get the data. So what is NoSQL? NoSQL means not only SQLs. So people are using in NoSQL HBase, Cassandra, MongoDB. These are the NoSQL database, and each database is specific to their goal. Like a Cassandra is a documentary database that like that web page, entire web page data we can store in Cassandra and we can do processings. So other than that, if we need some custom API which is very important for our business logic or BO or BI tools, other than that framework, we can write this code in a Java and C++. So the prerequisite for the Hadoop is should have a SQL idea, should have a Java, C++ basic idea, and should have a good good architecture concept. Like that, it's not like that how to do. It's like that why and where I have to do. And the analytics side, if I am going to tell you the analytics side, people are using R, which is a very fantastic statistical tools which will support you to start analysis, and it is a purely open source. Previously it was that as a SAS, now it is a very open source project came, which is a competitor of the SAS again, and it is a R which is for the analytics purposes. Again, if you are doing some job for the OLTP support, people are using HBase or some good algorithms out of the Hadoop framework which will support you real-time data access. Like that, Cloudera introduced one of the API and one of the component is known as the Impala, which will support you. Just 3 months back they introduced Impala services. So Impala is a real-time data access. The Hadoop, this is the positive point. The demerit of the Hadoop is that Hadoop is not for the small job or the small data set. It's not for small data set. Hadoop is only for the big data set. If you have a small data set, what you need to perform your job, that case is better choose the RDBMS rather than choosing your Hadoop. Because Hadoop, the problem is there is a lot more latency involved, because Hadoop framework is a heterogeneous and a combination of heterogeneous component in a homogeneous way. That is why each component need to start, and that component will take some time to start itself. That is nothing as a that is nothing as a spillage time that we cannot reduce at all, because the inherent latency involved with the Hadoop. That is why Hadoop is telling that do better way and choose right framework in a right place. What is the right framework? If data is so less within a GB, do it your operation in RDBMS. If data is too high, more than 1 petabyte, do it in your Hadoop framework, which I am going to support you. And if the data is like a mixing of all the data, sometimes I will get a less data, sometimes I will get a huge data. So you have to put a model in between that, which will determine either the data, if this data is very less, and it will do through the Impala services. So the today market is telling Hadoop is a green focus to the big data, and it is a friendly technology, and people based on their expertise, based on their technology experience, based on their concept and the implementation way, they have to choose their right path, either which component of the Hadoop we should use. It is not like that there is no thumb rules. We have to use like all the components in your project, not like that. You have to choose right component out of the framework. So that's all about the Hadoop, how it is working, how it is distributing the job, how it is reducing the cost, how it is very cost effective, and how in the future people are only dealing with the big data. So how it will be how it will give the benefit to the people who to deal with the huge amount of data, not for less amount of data. Do you have any questions?
Yes, Samir. So think that it will be a general question. Think that there is a Java application with the entire. There is a data layer as well as business layer and the application layer. So from the application layer, we will be getting some inputs from the customer. In business layer, we are doing some processes, calculations with our data, and we are producing output to the back to the presentation layer, as well as we are storing into the data layers. This is a Java application. Application layer will be an request that can be a URL. So as you said, it can be a huge data. So where the Hadoop will place, what the benefit by using Hadoop I will be getting?
Yeah. So what is the size of the data which we are going to deal with that?
So think that we are having enough data to deal with the Hadoop.
Think that 50 terabytes.
Great. So let me tell you same thing what you discussed, what you asked me, because then only I can give you the right answer. Your question is you have a presentation layer and a n number of clients is interacting with your business layer, that is your in Java, and what you model your BO business object is in Java. Am I right?
Yes.
And you are doing some operations, and you are doing some analytics, you are doing something, and after that data, whatever you are getting the data to analyze inside a BO, that means analyze inside a Java, is a huge data. Am I right?
Yes.
Okay. So the Hadoop placement in this place is that the client is a presentation layer. Let it be the presentation layer. It is dedicatedly separate. There is no question of Hadoop will be there. There is no question, because Hadoop is not for presentation layer. Second is that the BO logic, whatever you implemented in the Java direction, so the BO is fetching, the Java API is fetching the data from your RDBMS right now, right?
Yes, it will fetch from both end. It will get from application layer as well as data layer. Then it will be doing some process, and again simultaneously it will send to
Okay. So for that, I am going to share you the right diagram, right architecture, which will give you the more benefit rather than I am telling something. It is the right. Just give me. See, this is the right diagram for you. See, the web portal is our presentation layer.
Yes.
Now that web portal will interact with the RDBMS, what exactly you guys are doing. And the BO logic, whatever we have, it is in this box. Is a Java running inside that? Got it?
Yes.
Now the entire process, I'm not going to take from the BO logic from this server. Instead of I'm processing here, then get to here and fetch the data. So now, if the data is so high, see, this is the offline data input, offline data output, and some of the offline data from the various research assessments from the social media. So entire data, if I will put a landscape, just a minute, I will put in a template so I can edit
So
it.
Samir, so
now,
basically, Samir, so what you're saying, okay, so basically what we have it is we get like so the huge amount of data in XML format, and you know there is like a lot of transformation we do it, and after transformation that data goes in the database.
exactly, the transformation what you are doing, it should be there in Hadoop engine.
Okay.
And the yeah.
Okay, and one more question. So basically, you can do transformation, and also I think you just touch base here a little bit on HBase and R. So basically, all the not HBase but R and Mahout, right? That's what you mentioned for the analytics. So that piece can also be done at the Hadoop level, right? And then it
exactly.
can be
You are right.
on
you are right.
the web portal, right? So the
exactly,
web
you are right.
Okay, so on the web portal, basically we can query like some data from Hadoop, and we can query some data from OLTP environment, which is a database.
Exactly. Some data, if you are going to query from Hadoop, there is a Impala services, which is a real time. There is no let.
Samir, we missed you. Hello?
Hello?
Last couple of minutes. We did not heard anything. It was like just black.
See, whatever you discuss, it is perfectly right directions. So what you have to do, in that case, there is a component in a Hadoop you have to use to interact your web portal with the Hadoop through Impala. So it will give you more feasible solution to you and very quick result. Believe me, if data size is some billions of records, does not matter. It will give within 1 to 2 seconds, not more than that. Is it fine for you?
Oh, it's perfect.
Impala
the customer will be happy. He will be dancing.
Yeah, perfectly. If you will run this same query in Teradata or HANA or in Oracle also, it will take at least 5 seconds to produce you the result, even though it will be optimized. But I am giving guarantee for Impala, it will give within 1 to 2 seconds.
Impala is a tool from Cloudera, right? You mentioned.
Yeah, Impala is a one of component, another component which is for real-time data access.
But that's not the open source, right?
It's purely open source. Everything here is open source except
the
support.
Impala is open source. I thought he used. Okay, I thought the Cloudera's all the products are kind of the licensed products.
No. All entire, not Cloudera. Who is giving the Hadoop support? Each and every one has to give a free, not any charge. So that is why each and every component from any vendor is a free, except the support. If you are taking support from there, obviously support means resource, right? Physical resource. That means they will charge you.
Okay.
Any questions?
No, it's good. I have one more question. So, did your question answered, or you still have?
Yeah.
It's free to ask me.
No, just before I asked Samir that regarding that Java application.
Okay.
So what will be the Hadoop port on my application?
Yeah. In Java application, what we have to do now, data is in various resources. See, you are looking one elephant, right?
Yes.
That see, within a red box, you could see one elephant, right? That elephant is nothing. The elephant is nothing. Is a Java-based Hadoop API. Is a Java-based Hadoop API. Whatever you wrote the code, that transformation code, that has to be there in Hadoop through Java layer.
I have to plug in Hadoop application into my Java.
Exactly. There is a plugin and there is a jar file. Just plugin means you know that you are a Java guy, you know that. So purely the jar file will be there.
Taken as a resource reference library, it will the API will be available in.
Exactly. You are perfectly right. And
okay,
that
so
will do your,
Yeah, that will be a plugin component for us.
plugin component. Okay, perfect. So Samir, one more question on my side. Okay, so the couple of things like R and Mahout, right? The analytics and predictive analytics. That's what you mentioned, right? So what are those components? I mean, are those like kind of you know, sits on the top? I know, I mean, they will sit on the top of HDFS, but basically they have some kind of standard template, or how do they work? I mean, why people don't use like only R or only Mahout, but it's necessary to use both?
Yeah, okay, very nice question. Good. So I'm just bifurcating the R and Mahout. What is Mahout? Mahout is a engine on top of HDFS, and what is R? R is also one of a component on top of one of a third-party component on top of HDFS. So R is a third-party component. There is a connector through which we can connect to the HDFS through R. So R will do very fundamental modeling, but Mahout will do some predictive analysis, segmentation, and some audience filter. Like what is that? See, I'm giving one thing. I have a huge data. Out of that, the data is related with my client. Which client is bad and which client is good? How to know that? R will not tell you these things. Why? Because to do this process in R, we have to write lot of code for that. So rather than writing lot of code inside a R to do out of text, how to extract the emotion? Let's assume that the text is, hey, why not you replied that as soon as possible? Why you replied after 5 minutes? I was so busy with that. One sentence. Again, you are replying that, sorry for that. I was having some problem. Can you please bear with me this much of this time? So in next session, it will not happen like that. Now, third question, third you are replying. Oh, okay, yes, nice. Let's go on. Now 3 sentences I told, right? Very practical sense I am telling, and we are using. That is why I am giving the right examples. So what happens? We are extracting the emotion. What exactly emotion you are? What your face or what your thought process while asking the question and giving the answer. And from the question and from the text, we are extracting the emotion and we are putting into in a way like that. Either that guy is like a ranking based. What is the ranking for a particular guy? Either he is satisfied or he is not satisfied, or he is very satisfied, or he is good or bad, like that. We have a rating, right? So to do this operation, Mahout has its own API. If we'll pass the data set, it will give you the result. No need to write any, no need to write huge code, but you have to write somehow you have to write some block of code. But in R, what happens? You have to do, because you are, see, that time what happens? You used Mahout, so Mahout will determine which sentence is a outlier sentence. Outlier means not usable. Which sentence is a very good, I have to use it. So that determination capacity, Mahout has its own algorithm to determine it. But R is like a C. It's not kind of C++. It is purely C. You have to build your API which will determine the sentence which I am getting from client, either it is a good sentence or bad sentence, and how to decide which one is outlier and which one is mean, which one is median, which one is mode. and which one is linear regression, which one is logistic regression, and which one is linearly distributed and homogeneous regression. That pure concept of the statistics, if you are using in your application, better that you should use R. But some of the business is looking for, instead of statistics, they are looking for formulated statistics, means statistical framework. That statistical framework is nothing as a Mahout, and the statistic model nothing as a R. So by using R, we can build 1,000 number of Mahout. Got it?
Oh, so basically what you're saying that on the top of HDFS there will be the Mahout, and on the top of Mahout there is R, right? Is that right?
Which is a purely core, which is a purely core concept. But Mahout is totally written in Java, which is a replica of a R. What exactly it is doing?
Okay, so you are saying that Mahout can do whatever R is doing, plus it can do even more.
Exactly. So Mahout equal to R plus some analytics concept, but R equal to purely C. That looks like a C concept. See, I have to print the Fibonacci series. I have to print 3 quadrant of the number. I have to check either that number is good or bad or less than or right than. This logic, what exactly the API, it is not available. I have to construct the API. That case, people are using for statistical operation purposes, people are using R to find out the mean, median, mode. But Mahout already, if we will give the data set, Mahout automatically determines what is the mean, what is the mode, because already they written the algorithms.
Okay. And,
like Mahout is a automated tools.
Okay, so does it has like some kind of sample what should I say, like like in order to define the predictive analytics, right? I mean, so those predictions, so different behavior, like you just give like one example, right? Like the customer behavior, right?
Yes.
So same way, do they have like some sample task which can be like directly selected, which are like industry standard, right? So suppose if I'm in YouTube, so it's like I'm watching certain type of videos, so this is what my liking is, so based on that it only gives me like that type of videos. So does it have like that kind of filtration? So basically you can choose based on that list, and then that will go ahead and create those kind of predictive analytics automatically, or do you need to write your custom code all the time?
No. You no need to write your custom code. Is having lot of APIs which will support you.
Okay.
Is a custom method.
Okay. Oh, good. And then another question is, so on the top of Mahout, does Mahout have any web engine integrated, or it does work with?
Mahout is a transformation engine. That's all. Okay. And on top of that, you have to use your web engine.
Okay, so you can use anything like either Apache, WebLogic, or anything, right? Or like Oracle Effect.
That diagram, whatever I'm showing you, right? Audience Manager Technology Landscape. What exactly the vertical line, left to the vertical line and right to the vertical line. Right to the vertical line, whatever you want to use, does not matter.
Okay.
And be a WebSphere, WebLogic, JBoss, or Tomcat, Apache, whatever you want to be in a web portal, you use it. Not a problem, because that looks like a plugin, right? Plugin to an existing application or to the Hadoop only. So Hadoop is a backend, purely for backend engine for transformation engine or analytics engine, like to handle huge data purposes.
Okay.
So there is obviously integration layer.
Okay. And what is Cassandra you mentioned?
Yeah, Cassandra is a documentary DCS system. It is a purely DCS. What is DCS? Documentary content system. So what exactly? Suppose you could see your web page, right? And the web page consists of homogeneous or heterogeneous context. Now I don't want read line by line and put into the DB. So instead of doing that, I will scroll entire web page, I will put into the DB. So Cassandra will define key associated with value. Value is nothing as a page scroller. So that is another way of NoSQL database.
Okay.
And it's purely this framework, this landscape, whatever I am sharing with you, that is purely it is it is in production. We already implemented it, and I am giving you one case study that we could. But Cassandra, it is not recommended that you have to use Cassandra. It is based on deterministic algorithms. Either we will choose Cassandra or HBase. It's based on our business requirement. It's not like that everywhere we have to use.
Okay. So Samir, what kind of skill sets we needed in order to get beginning to work on this Hadoop implementation for our application?
Yeah, I think I already discussed, and that Java basic, you should know the Java basic and SQL, that's all, and you should have an idea
Java
of
and SQL, right?
systems.
Okay.
That's all, and you should have an idea of like basic Unix command, create directory, remove, blah blah. That's all, nothing other.
Okay, so all these platforms only works with the Linux OS or Windows also?
It works for it works better for the Unix and Linux, but it works for the Windows. It's not recommended for Windows. It's not recommended for production. It will choose a Windows. It is not pure. It is purely not recommended.
Okay, okay, perfect. Okay, and what's your experience, it's like how much time usually does it take for enterprise class system in order to get this one implemented? I know, I mean, there is like lot more involved basically if your integration points are more, right? I mean, if you're doing like lot more transformation. But what's your experience like? Usually, like 15, 20 different types of transformations, and doing like 20, 30 different types of analytics. What will be the timeline usually people take, and how many resources?
So no, it's see there is not exact figure I can tell you, but exact estimation I can tell you. The hour basis is then based on the hour basis you can define it how many resources is required. So it's based on the algorithm and transformation what is the complexity. But average case I am telling you, average case people are telling if the guys is so not so is a known person to the analytics side or a transformation side, he will not take much more than for one transformation. He will not take more than 2 days. Means 16 hours maximum, and it is for initial. But when it will go to the some next version like that, initially I did 2-3 transformation. After that it will be like within 1 day I can complete 2-3 transformation at a time.
Okay.
Because initially it will take time. It is
right. Yeah. Right. Because there is a learning curve, anyways, right?
Yes.
Samir, can you share us the link where I can get the API?
Okay. So there is a org.apache.com. That's all. org.apache.com and type Hadoop Apache API. Or you go to Google page and type it Apache Hadoop API list. Then it will show you entire list. It is very simple. It is nowadays it is very first ranking page.
Okay. So Samir, are you the one who gives the full-fledged training, right? Is that right?
Yeah, I am the one person. I am taking online training.
Okay. And as a part of training, are there any hands-on labs?
Purely based on labs only.
Oh,
Because
okay.
you have a laptop, right? Because it is
Yes,
one to one. It is not. If you are not getting, we will not go next class. We will stop and we will first clear that, then we will proceed it. It is not like that. We will skip and we will go. It is not. It is
okay.
not template based study. Because template based study is good for the fresher. I don't believe
Right.
template based studies is not. I only prefer that case studies based study.
Right.
That is why my objective towards the training will be define a case studies, define a problem, solve it in front of everyone.
Okay.
And if we'll cover entire API, then case studies if we'll start, it will be easy for you. So otherwise, 2 hour, 1.5 and 2 hours of session, it will kill you. You will not feel energy to keep on listening all the things. So it should not be a if someone is looking for template based or a slide based training. It's sorry, because we are giving before one day we are giving a document to each and every student. But whatever we are going to cover that class, suppose tomorrow class we are giving today only. So you should have an idea, you should have a question, you should bring the question. But the problem exactly what we are going to solve in this session, it is purely it is a interactive problem. Whatever you define or I define or anyone defined in a case study, you will put and you will solve that. This is a purely lab.
Okay. Good.
And we are providing a soft copy documentation for each and everyone.
Okay.
Is it fine?
Yeah, I
Yeah, fine,
think
Samir.
that's fine. That sounds good,
Okay.
Samir.
Thanks. Do you have any question?
No, Samir. Are you from Andhra Pradesh?
No, I am close to